Um, Actually, I'm going to talk about web application security, and it has a Drupal-like focus because mainly I do a lot of Drupal work. Who am I? I am a freelance tech-like person who does a lot of work. And actually, can you see this? I mean, it's barely, right? Oh, right, cool. Basically, that means I'm going to do a lot more talking, but I can do that. Can I get some water? Actually, is that possible? Water on the table. Oh yeah, well, as long as it like water. Thanks. Um, Basically, I run my own company, which does a lot of web work, but also back office integration, and I do a lot of workshops, security audits, and everything like that. But I will not bore you anymore with my personal stuff, except that I've been around web development since like HTML 3.2, which is pretty long time ago. JavaScript I learned at the Netscape Navigator 3 thingy, which basically means it's ancient. But let's go into the actual subject first. Web applications. In the past, let's say 10 years, web applications have evolved from statically served pages to actual multi-tier platform integrated stuff, multi-front end, multi-device strategy, but also very much interactive. This whole approach means a complex mixture of interconnected components, which basically means more things that you can actually hack, more things to explore, more things to secure, and well, is that something to be scared about? I don't know. Most of my clients usually are, actually. That's why they probably call me. But it simply means that you have to focus on the actual risks the different parts of an infrastructure actually offer. This is really unreadable, I think, but I'm sorry. Risk-based approach. First of all, what are you defending against? There are a lot of different types of risks you can assess when looking at an application. What is the goal of the application? Is it an e-commerce site which has banking information? Is it a communication bus type of thing which requires constant uptime? What are the risks in the infrastructure? Actually, if you look at the underlying server, web server or operating system, the basic risk you have there is collapse, like overloading, like failure. And actually, the worst thing that can happen with that is that your website will not be reachable. This can be really bad if you run a business and you need to sell stuff. Then you basically want your site to be available as much as possible. But if the site is down, no information will leak. So this can also actually be a defense strategy to attacks like DDoSing and stuff. Just switch the damn thing off and sit it out. Database server, that is more severe. If that gets compromised in any way, your information gets altered, and altered information could considerably mean problems in your supply chain, problems in the actual flow of the application. Um, so that is a different type of risk. And the application itself, the web application, if that gets compromised, then it opens up a whole new area of other problems like altering information, putting pornography or stuff or extremist views on a website. And if you're like a government which has something to do with, say, immigrants, you basically don't want to have a swastika on your front website. So that is actually something you want to be protecting against. So first of all, identify the risks your application is exposed to. Second, determine why somebody would like to target your application. What could be the interest? Are you handling privacy secured information? Are you handling bank accounts? Is there a financial gain by hacking your application? Because then you also have to think about a whole chain of protective measures all the way from the application to the banking system and implement some more checks and balances. So try to get into the mind of the possible attacker and at least have some basic intelligence on why somebody would want to harm you. Um, The keywords here: availability, confidentiality, and integrity. Availability usually is the least big problem. If a site is unreachable for a couple of minutes, most companies will survive. Confidentiality, well, personal information, you don't want to have that out in the open. In the EU, we now have also actual laws which require data leaks to be published. So if you leak data, if you're a web shop and you have to be honest to your clients about this, this would probably mean they would find another supplier who can handle their data better. And integrity. Integrity simply means that the data that was once entered in the platform and was validated during that entrance in the platform still is in the same form and still is reliable. Uh, well, why is this a problem? Direct loss of revenue due to an offline web store. For most shops which do e-commerce, it is becoming the primary point of sales channel. Physical shops are closing mostly, and web shops become more and more important. Loss of potential customers due to that, or bad publicity. Oh, this is really nice and hot. Um, yeah, thanks actually for that warning. I was prepared for that. But also, incorrect information could lead to a serious malfunction in the process, and this incorrect information doesn't necessarily have to be entered through your platform itself. It can also come from a third party implicating you, and in that case, a viable strategy can be to have a PR strategy against that kind of situation. Example for that matter would be the Project X party somebody threw in a little town called Haren in the Netherlands. I think it was last year. There was this girl, 16 years old, who published her birthday on Facebook. A couple of 10,000 guys and girls showed up in a village which had also a couple of thousand inhabitants, which was a problem because they only had like 3 police officers on the site at that time. There should have been a lot more PR strategy behind that one. So security, also when I do audits, I don't necessarily only look at the system side of things. I also look at the procedures which are in place when an actual event happens to simply see how the response will be from a specific client. And I think that is at least half of limiting the damage is actually giving good communication to your customers. What is a hack or attack? Well, it's pretty broad. It's basically anything you don't want happening, like misuse, false requests, or your application is being scanned for vulnerabilities, etc. But basically, security, whether it's physical security or digital security, it means simply closing up doors that shouldn't be open anyway. The only trouble is in web applications that the damage and the information spreading regarding a hack or damage is going lightning fast, and you're screwed. All right, this presentation is done in just like 2 parts. I'm now going to focus on the OWASP top 10. I think most of you will have heard about OWASP, and if you didn't, you should look it up because they offer a lot of very valuable information regarding best practices and attack factors. I'm going to run through the top 10 pretty fast, so we'll get into the last part, which basically means a lot of advice regarding how to harden applications. So bear with me. Injection is basically the worst kind of problem and the most encountered problem still in current day web applications. And the trouble is that it's actually pretty easy to prevent. It basically means just validating anything you get into your application, no matter where it comes from. Validating anything that comes also from a database or also from the file system itself. What I encounter pretty often is web applications which are pretty tight on the user input validation side, which validate every field in a form really nice, have salts in passwords and stuff like that, but on the other hand, if something comes back from the database or from a local file, nothing is validated. But that can also be altered pretty easily. Also, validation, where I look for is, especially in PHP, which is of course a type unsafe programming language. I look at the data types in a database and I simply check if types are being cast to the right format before communication with the database occurs. If you have like page ID in integer formats, then simply the application should do a cast to the integer format before it's communicated with the database. And because it's simply no use to accepting anything else. These are all telltale signs. If this is done right in the application, you can pretty much count on it being a pretty secure, or at least the developer has been aware of that. What I also look in applications is whether an application handles or uses a generic form component to do input validation or do form handling anyway, or if all the forms are being generated per form basis, or even worse, in client-side code. And really, client-side filtering or validation is no validation at all. I mean, everything should be checked at the server level before using any of it. Um, File uploads, another very nice injection possibility, especially since a file can, or at least the browser will typically lie about the MIME type which it sends towards an application. So if you have an application which accepts file uploads, then simply check if the application does some kind of MIME checking and restricts the input formats for that. What I mostly start with, and this is written with PHP in mind, but basically it works for just about any other platform. I look for usage of raw input validation or raw input variables. I will simply search for like get, post, or request in PHP applications, and if I see them being used throughout the application, that's a red flag. Uh, Direct usage of input validations of input variables should, in my opinion, always go through a validation component, and after it had gone through that component, it should then be used. So I also check if forms are actually validated server-side. I will check which database driver is used. Is it up to date? Is it like PDO in PHP sense? Because that also has some security advantage. Um, but simply, I'll check if from both the client side, the browser side, as well as the file system side, if these validations are in place. Cross-site scripting, it's another type of favorite attack vector. It's basically the same as injection. It's simply including something from a source that shouldn't be there. And also, if you do validation on the actual insertion of the data, once you will use links from other resources on the internet, you cannot suffice with validating only on input, because these links can be redirected to basically any type on the planet. And what you should, well, actually, I think it's not a very good practice anyway to utilize externally fetched user configurable input in an application anyway. I think that that should be banned. But there are use cases. For instance, if you look at image files like avatars, old PHP BB implementations, I don't know if you know it, but it's a forum software. They allowed you to reference an external image as your avatar within the platform itself. Well, that's actually fantastic, because with PHP I can also generate images dynamically. So what I could do is I could make a PHP script which actually had the extension PNG or JPEG, but when it was loaded, it would display an image. But on the other hand, I would be able to read cookies. I would be able to pretty much get into the session data pretty easy. And that's all because somebody simply referenced an external image and did not validate the MIME type or did not check it. Um, how to audit? Yeah, well, again, check for injection attack vectors and also uh, test if you use or if an application accepts external input like HTML. Check what kind of filtering is done on that. In PHP, you have this thing called strip tags, and strip tags is, well, some method which probably is very easy to use because it's only one method and you assume that it will strip all the HTML. Well, in fact, it won't. It only looks for the opening and closing brackets around the tag and strip that out. It produces malformed HTML. So, and basically, there are better solutions for it, like PHP input filter, which is a whitelisted based input filter software. I will check in an application if those kinds of filters are used. And if these filters are used, how are they configured? Are they configured by whitelisting patterns, like only allowing breaks or paragraphs, and which attributes in these are used? I will simply look at how that is done. Also, I will look for the usage of a server variable. The server variable in PHP is actually information which is provided by the Apache web server, which most people will agree upon that being part of the actual infrastructure that should be reliable. Well, it's not, because actually there is also client-side provided information in there, like user agent strings and stuff like that. These can be manipulated pretty well. Um, you can actually, in the user agent, even throw JavaScript, and if you then display it, here we go, cross-site scripting. Another attack factor, broken authentication and session management. This is a thing actually in the early days of Google. It was, at least so I'm told, mostly used as a porn image finder, and that basically was because most porn sites would actually authenticate only on login, but all pages behind that would have like incremental updating integers as IDs. So Google would crawl that, simply bypass the login form, and index every biological picture after that. That happens actually with a lot of applications. A lot of applications don't do very well authentication checks after a login has occurred. A lot of applications actually simply set a session variable, I'm logged in, without any context, simply accepting that. That's fine if you don't handle sensitive information at all, or if you don't care about your data. But what I will look for in authentication and session management is there a generic universal component in the application, like a authentication class, which handles the testing of the authentication by looking, for instance, at IP address changes or user information agent strings and stuff like that. These are pretty good ways of checking between requests if a user is still the same user. Uh, it at least gives an indication. And if I see checks like session logged in, then that basically means I have to dig a bit deeper to see what is actually done. Um, Other piece of advice which I give to developers a lot, and what I look for is if user IDs aren't integer based, because if a user ID is integer, then you can pretty much count on one being the admin user, and which will basically have like God rights in an application. And so use UUIDs for that, or hash this. Of course, if you hash something, then add salt to it. Um, and oh yeah, maybe also I actually also check for the occurrence of admin in an application, because hard-coded usernames, you will not believe how often I see in applications, if user is admin, then do this and do that, and well, makes it really handy. How to audit this? Well, again, tricky. Also, test where session data is stored. Check where session data is stored in the system, because PHP session data is out of the box simply a text file with a serialized string of PHP variables. And usually, if you have a badly configured web server, then the temp folder is the place where these files will be stored, and the temp folder by default is mostly world accessible, at least pretty easy. Um, and also make sure that session cookies are HTTP only, so that they cannot be referenced by JavaScript. I know it is a client-side thing, and I just said client-side validation is no validation, but the title of this talk is actually Web Application Security is a Layered Cake. What I would look for when auditing an application is what kind of layers, how many layers are actually in place to demotivate an attacker, because security in basic means looking a little less unsafe than your neighbor, so that probably they will take the neighbor and not your application. So put in place multiple layers, even if it means client side, it will at least demotivate. Another attack factor in secure direct object access. This is also something that has to do with the session files I just told, because if they're in a publicly accessible place in the file system, then yeah, it's pretty trivial to hack that. What can you do against this, and how can you audit this? Well, basically, let's look for HT access files. If at least something at that level is done, they have a pretty severe performance penalty actually on Apache servers, so I would not recommend this as best practice performance-wise, but at least it gives an indication. Open base there, I don't know, anybody heard from that? Yeah, cool, good. It's simple, it's a configuration item you can set in PHP, and it simply restricts the folders PHP will be looking in during runtime. It requires nothing but simply adding the web root. AppArmor, also a very nice piece of software. I don't know, anybody heard from that, AppArmor? Oh, okay, cool, I will go into that a bit later. How to audit this? Well, simply check if these kinds of measures are in place. If they are, then you can at least assume that the person who installed the application on the environment had some notice of security or of best practices. Cross-site request forgery. I think I'm going to have some water again. A lot of these attacks are actually pretty similar once you put them aside each other. But cross-site request forgery is basically how to make the application think that a request originated from the application itself, while in fact it has originated from somewhere else. How to audit? Check if in forms there is actual validation on the refer IP in the form handling component. Also, check if salts are being added or unique IDs are being added to forms which are revalidated. Again, it's really easy to, in a form component, put a hidden input variable with some kind of unique number or hash and revalidate that on form submission. This is pretty easy preventable, and it's pretty easy to audit this. If a generic form component is used which utilizes this method, then pretty much you're safe. Well, another favorite, security misconfiguration. And here you enter the crossroads between the actual developer of the application and the systems administrator, which is managing the application. Because no matter how hard a developer tries to secure an application, if the system administrator puts it in a world writable directory or anything interesting like that, you basically still have a problem. You can pretty much prevent this by simply checking for if a firewall is in place and actually being configured or simply opened up in default modus. Check also if all the different components of an installation run with specific user accounts. If an Apache user is utilized for the web server, for instance, or if a MySQL user is used for the database, but also check in the database itself. If, for instance, for updates for the database schema, you can use a different account than for regular operation, because in regular operation on a web application, you normally will not have to change the database schema. alter tables and stuff, you can simply run with a pretty much read-only account. And if I audit an application infrastructure, I specifically also look for this. It's a pretty good sign if a system administrator knows what he's doing. Yeah.
You also look for clear text passwords stored in configuration files.
The
And how
que-
do you prevent that, like MySQL password?
Um, the question was, do I look for clear text passwords in files? Yeah, I do. Trouble is that some applications require a certain level of this thing. Like if you have cron backups from MySQL databases, uh, I will check if those are made from script files within like the root user directory, which is not readable in the rest of the file system. But I also check, I simply do a file system scan of things like login or admin or password and stuff like that. Simply see what turns up. It's amazing how many times you can find under the like administrator account in the home directory, you can find indeed clear text files called logins or server stuff. Yeah, that
And how do you suggest the solution to prevent that, to allow authentication without storing the passwords in clear text?
well, next to a lot of naming and shaming inside the organization, I have to run up. All right. Oh, how do I prevent? How do I prevent that? Actually, it's a lot of education. If I do a security audit, that's usually combined with a workshop for the system administrator, actually explaining this. But there is no measure you can take against human stupidity. If somebody actually wants to put clear text passwords in like text files, you're screwed anyway. And if he doesn't or she actually, because it happens a lot that we actually encounter women on the workplace these days. It's just really nice. Um, if they want to put their passwords up in the out in the open, they can simply do that. But I will actually look if like K-Wallet is installed, or something if is actually used to manage the passwords. So that is something you can look for. But basically, this is just education, 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 and
But KWallet is on client side, right?
yeah, but that's in my case also part of the. Oh, sorry, maybe I wasn't clear. K-Wallet is actually on the client side, but if I do a security audit, that also includes the way a system manager is administrator is working. If the server itself is nailed down rock solid, and the administrator still has everything in clear text on his personal laptop, yeah, then basically isn't that secure as well. So that is part of, in my opinion, that should be part of an audit. See how the procedures are in place within a company, how to handle that kind of data. Um, is that actually a satisfactory answer?
Yeah, yeah, it was mostly referring to the server side, like how does PHP talk to the database, so where does it store the password, for example.
Uh, PHP connection to the database is done in clear text. Normally, it's done in PHP scripts. But I will look for if the if the configuration scripts are in the web root and how are they constructed. If it's a like PHP file which only contains an array of information, if somebody calls that script from the client, it will not usually display anything, so that's usually not a problem. But if you have an ini file, for instance, which is a clear text file, and you will request from the web server the config.ini file, it will simply display the text, which is pretty bad. So that is where htaccess actually comes in, and you can actually rewrite which files should be readable or not. But best practice absolutely is like not store those things in the web root at all and check for that.
Yeah.
Insecure cryptographic storage. This is also a hard part because it's very hard to actually investigate the whole chain of devices and network hubs which go from client to server and back. But you can actually have a few rules of thumb. Uh, Hash anything you do not actually have to reconstruct and add salt and check for that. I mean, if a user enters a password in an application, there is no need at all to have that in clear text in the application. That should be hashed at all times with salt. Um, and privacy-related or financially sensitive data should always be encrypted. And it actually, this again is putting more and more layers in place to simply demotivate a hacker after attempt number 36 to like walk away. Um, oh yeah, and also really important, a lot of clients, especially e-commerce, they have the tendency to simply want to store anything because they can. Maybe we can use this in future for some unknown use case. Well, I don't think that is a very valid strategy. I think you should always check that the minimally required information set is being stored to facilitate a process and nothing else. So if basically part of an audit is also simply getting the data model from the application and discussing that with the client and simply asking, what do you do with that information in that field? How is it relevant in your process? And if the answer is, oh, we might need it one day, then that's usually something to flag about. Failure to restrict URL access, that again has pretty close connection to broken authentication management. Authentication should be checked at every request, and it's pretty simple to audit that because most applications use some kind of routing component at which the request is done, and simply you can look at the routing component and see how the re-authentication is done. A really nice new attack vector comes from web service APIs. It's not that new, it has been around for some time, but actually um, what is often forgotten is revalidation also for web services. These are also entry points in your application, so they should have the same type of authentication. Um, Insufficient transport layer protection, that usually that is actually pretty much connected to also the cryptographic side of things. What to do against it? Well, simply use strong cryptography. You can actually look at the NIST and ANISA websites, NIST of course being the American organization and ANISA being the EU equivalent sort of that. There's a lot of information there about strong cryptography, how to implement that and do that, so I'm not going to go into that in detail right now. We have unvalidated redirects and forwards. Again, re-authenticate, and check the re-authenticate. And by now, actually, we have gone through the OWASP top 10, and that is actually not all at all, but it is a pretty good start to check against. And it also, clients who request security audits are pretty well informed usually about the list themselves. So in reporting to a client, I would actually suggest to use the OWASP top 10 as a starting point. But it also means raising awareness in client that actually this OWASP list exists and that they should look into it once in a while. And like I said, being secure is looking a little less insecure than your direct neighbors, mostly. All right, that about covers the custom-made applications, but if you use like off-the-shelf applications, what do I audit for? Because actually most of the times clients use off-the-shelf CMSs like Drupal or Joomla. I'm going to go into Drupal a little bit here. And they don't have that much control of how the application is developed in the first place. So, but that still doesn't mean that they cannot harden their security. They actually should still apply the layer cake approach on every aspect, and you can audit for that. Well, what is Drupal? I think most of you might know it. What does it do out of the box? Actually, it has a pretty decent security level out of the box. It does a lot of input-output validation and escaping. It has a lot of authorization options out of the box. So it's pretty cool. What I would check in Drupal implementations, if anybody actually took the effort to make different roles in the authentication profiles, because I also encounter a lot that you have sites with anonymous users, authenticated users, and administrators. And if I only find these three groups, then that will probably mean that the authenticated user can do way too much. my rule of thumb would be that any user who would have to have any kind of alteration authorizations in an application should have a specific role describing what they actually do in the application, like text editor or whichever, and don't throw anything on the generic groups. If that is actually to check. On the server level, basically, if there is a component on a server that isn't used, well, it should not be installed, or it should not be started. Uh, I'm amazed every time if I check a process list on a running web server, what kind of nonsense is running there. I mean, if I have only a web server which doesn't have any other specific goal, then indeed there should not be like KDE on that, or LibreOffice, or Mozilla Firefox, for instance. Why would that be on a web server anyway? Um, it's or FTP servers also. This is, of course, the most common way to update a web application is by FTPing new data up on the server. And, well, actually, the FTP server doesn't have to be enabled all the time. It can simply be enabled at the time of upload, or better, use SSH. And if a client uses SSH for updating or access, I will check if something like fail to ban is installed. Fail to ban restricts failed logins after a couple of times, which again offers a little bit of protection extra to brute force attacks. What I also check is if monitoring tools are in place, and if they are in place, if they are actually being checked. And also, if like a monitoring system would send email, I will test if it actually sends the email, because these systems are usually being put in place years ago. Infrastructure changes, new mail servers arrive, and it's actually impressive to note the amount of times that clients actually took the efforts to put a monitoring system in place, configure it pretty well, but then forgot that they switched mail servers. Also, of course, make sure all software is up to date with at least the latest security releases. Again, I will look for specific users for the specific different services. If this is in place, this is a good sign. And I will check for sandboxing software like AppArmor or worst case SA Linux. But AppArmor is a very simple platform. This is actually one in the education area. If you have system administrators which have an actual important role in the process, I want to educate them about AppArmor, because it is a sandboxing environment for all kinds of applications, and this is something that is really easily implementable and it works. That is for the server or OS part. I will also do a scan for world readable directories, stuff like that, and basically, like I just said, check for files which are called login data or stuff like that. If you find stuff like that on a server, that's usually not a good sign. On the web server or web platform hardening stuff, first of all, check if HTTP methods are allowed which aren't used by the applications. A lot of applications, although RESTful applications start to use the whole HTTP spectrum again, but a lot of web applications only use get and post. So why should put or anything else be allowed if the only thing the web application really needs is get and post? If you have a misconfigured web server, for instance, with put you can actually overwrite data, and that is really fun to do. Check for software names and version numbers in the responses, and also check anything that is simply sent with a HTTP header, because a lot of information is not only a security risk, but why is it even relevant? Why do you want your user to know that you're running Ubuntu? I don't know. Do not enable directory listings, which actually occurs a lot. Only return error codes or generic error pages. And you can actually configure this also on mod security level, for instance. Um, I would advise mod security pretty much blindfolded, but you can actually also, with mod security, restrict the information that comes out of the application to the user. So you can check with a pattern if an error message is displayed or if stack trace information is displayed, and simply prevent that from going to the user at all. So simply only the HTTP error code should be returned. Also check what kind of load the CMS actually generates on generating 404 or 403 pages. Um, One of the most typical DDoS attacks is like utilizing random URLs or at least random parameters like IDs and stuff to fetch different pages in an application, but these pages are normally not there. So they will generate a 403 or a 404 message. But if you have this generated out of your CMS instantly, then you you're using a lot of resources because the CMS has to bootstrap, it has to connect to the database, it has to do a lot of actual work to simply output that a page is not there. You can also use mod security to simply detect that if a page hasn't been there like a couple of minutes ago, then it's probably not there now. And if somebody is brute forcing your application or DDoSing your application, you can simply instruct mod security to not let those requests go to the application, but simply return an error code on instant. This saves a really lot of resources, and I'll simply check if that's in place. Um, Also, I check for disable follow sim links because that opens up all kinds of interesting other possibilities, especially if an application has some form of writing permission to its own folders. With sim links, you basically lose where the application is going. Disable user web root dirs. Most Unix distributions or Linux distributions come out of the box with user web root dirs in the home directories. Um, Disable. Ensure that only whitelisted file types are outputted directly to the user, like MIME types, PDF or doc or JPEG, stuff like that. That should actually go directly to the user and not be interpreted. But apart from that, just check if everything else is being sent to the actual application or the interpreter, like PHP, because then with that you pretty much prevent a config ini file from being showed directly. Right. And also something I also encounter a lot is that if the virtual directory is being configured correctly, then on Apache the default directory is left open. So check if all aspects are protected. PHP hardening. Actually, there's a lot of configuration options in PHP which you can check to see if the application is being confined within uh, the execution space. And also limit system resources, like maximum execution time. Well, it depends on the application, but normally a web page should not take a long time to generate. So you can use like maximum execution time of maybe 10 seconds maximum, and then it's fine. I mean, if the application needs a lot of processing being done, it should be done asynchronously or by job queuing in Gearman or something like that. Max input time. Also, this is application dependent, but you would not want to like to have connections open too long because a web server can handle a limited amount of connections, and you want at some point the web server to simply close the connection, because else slow DDoS attacks simply work by opening up a lot of connections, keeping the connections open, actually not doing anything with the connection. So make sure that connections are being closed. Um, Input nesting level of variables with arrays, maximum input vars. The default in PHP nowadays is 1,000. A maximum of 1,000 get or post variables can be inputted into the application at every request. That is also pretty sensible to limit that, because else you can have resource exasperation. Um, if any application still uses magic quotes, um, I think that should be punishable by law. So you should check that. Open base there again, it's something pretty easily to check and implement. Display errors off should always be off. Repeat. Logging errors, well, that's always a good idea, of course, and check also if a monitoring service is in place and actually working. Register globals, I'm not even going to go into that. But also, expose PHP should be off. Why do you want a user to simply know that you're running a PHP application? Why is that relevant? Anything that is not relevant for the user should not be returned at all. And you can check for this. Memory limit and maximum upload size are, of course, application dependent, but they should be confined. And if you have a web application that is pretty resource intensive, like in case of Drupal, if you use the views module, it requires a lot of resources. Thanks. Then you should try and at least have a separate installment of the application for administrative usages, which you have a lot more resources for. But the publicly available application should be as limited as possible. You can check pretty easy. MySQL hardening. I sum up a couple of tips I already gave. Check for specific users. Check also in the application for specific users which are being used for different roles. Um, Also restrict MySQL and test if MySQL only listens to the web server or if it listens to the whole wild world. Why should that be the case? On production servers, or maybe in general, do not use phpMyAdmin at all. Prevent any direct access to the database files. Database files basically should only be able to be handled by the MySQL user itself. No other user on the system should be able to touch them. That is pretty easily checkable, so do that. Other tips are pretty self-explanatory. Application hardening. A lot of web applications like Drupal have a lot of modules which can give you a lot of information about the actual installation. For instance, Drupal has a status page and has a security review module which simply check if the installation of the application is at least close to the best practices that the project itself declares. And this is really easily installable and really easily to check. And if anything comes out of that, it should be fixed. In Drupal, check what the level of input formats is a user is able to use. Does a user actually need to input full HTML, every tag on the planet? I don't think so. Actually, a user, maybe some markup like bold, italic, stuff like that, but apart from that, why should most users have any other options in there? In Drupal, I will check if user ID 1 is disabled, because again, here we have the God modus, and if you have a session hijacking and a user can elevate to this user, or attacker can elevate to the user 1 account in Drupal, you can do a lot of damage. So simply disable user 1 and have some other user do the administrative stuff. Check the check if some scripts which are normally only used for installation and updates are simply non-existent on a production server. On a regular operating website, there is no reason at all to have install.php and update.php available there. I mean, you only use them for updates, so if you need them, place them there, update the thing, remove them again. Same is for README files. There is nothing more handy than having a README file saying, hey, I'm like Drupal 7.8. Ooh, that's pretty old. Now I know exactly how to hack this application. So README files should also be gone. Basically, again, anything you do not need for actual execution of the web platform should not be there. So you can check for that pretty easily. Also automated. You have a question?
Usually in the license text file, there is not the version, but the name of the CMS. Is
Yeah.
it okay for the license to remove the name of the service?
You can, of course, the question was, there is usually a license file which includes the name of the application there. My suggestion would basically to be remove the license file entirely. Anything you would not need in regular execution should not be there. So that also goes for license files. I am really getting out of time. All right, use AppArmor. I'm not going to go into it, but look into it. If you haven't heard from it yet, check it. It's really cool. It's really easily configurable. Use mod security, which is a little harder to configure, but actually really useful. You can install it as an extra layer of protection, and it simply is very powerful also in handling DDoS attacks. Any questions? One question I think I have time for. I can have more. Oh, that's so nice. Question.
Yeah, you had couple of remarks about restricting IP access.
Yeah.
How would you handle clients which are coming from behind multiple proxies, which will every request actually come from a different IP?
The question is, if you restrict IP access, how would you handle users which come from different IPs from like proxies? Well, basically, in that case, you don't. Actually, security should be about what is doable in both a usability point of view, a functional point of view, and a technical point of view. So if you have users which are behind multiple proxies, then IP validation is worthless. But you can check for other things. You can check for user agent strings. You can check for cookies being set. You can check for salts and all kinds of other options. So IP checking is just one measure. One more?
Question. Talking about the cross-site request forwarding,
Yeah.
the tokens that you generate should be based on something like the user session, or all of them should be randomly generated in every form?
The remark is that cross-site request forgery, you can pretty much prevent that by using tokens. And the remark you made is that these tokens should be regenerated at every request again, to make them unique every time they are being requested. I completely agree. If you use the same token multiple times in an application, it's worthless.
You use him based on the user session, because if you
Mhm.
generate different tokens, you fuck the user, because he can have two tabs open, for example.
Yeah, well, that's education, and it's also if a user has multiple sessions to the same application with the same forms and stuff, then that can be hampered by having tokens in the forms. Yeah, that is true, but it is again a different layer of security, and basically users should mainly try to utilize one entry point, but it's an interesting point actually. Yeah. But same is also for like mobile device access. Mobile devices with API consuming offer also a pretty nice challenge for token-based checks. Yeah. Where are you? All right.
Do you advise your clients to change the web server when that's possible and it is Apache, or do you think that Apache can be safe enough?
The question is, would I recommend my clients to run anything else than Apache? I think no. I would advise the client to run any web server the system administration department is comfortable with. And if that's Nginx, fine by that. If that's Apache, fine by me. The important part is actually to have a system administrator who knows what he's doing with the platform. And if for instance, that is Internet Information Services, that was a rhetorical remark. All right. Is your question answered? Cool. One more, maybe? No? All right. Then, oh, you have a question? Yeah, sure, absolutely. I will make them available, and else you can check my. I think I have it behind this. No, I don't. My website is hcderaad.nl. I will put them on there. So, actually, I'm done. If there are no, yeah. Thanks for staying.